Yes, sir.
Today's class we are going to continue this angular momentum. So as we have seen in our yesterday's class, angular momentum of a point mass. So in our today's class we will see a purely rotating rigid body. What is the angular momentum of a purely rotating rigid body? Then how to calculate it, and along with that some JEE questions also will solve. So as we have seen in yesterday's class, angular momentum. What is the angular momentum formula, everybody? So angular momentum L is equals to R into linear momentum. So that is what is the formula for angular momentum which we have studied. So if you have taken, for example, if it is a point mass, angular momentum of a point mass. So we got it, which is always true, everybody. Angular momentum of a point mass, which is equals to m into v into r perpendicular. Am I right or wrong? So r perpendicular only, which is equals to what we used to call r sine theta. Yes or no, guys? Please respond. So on that, along with that, there is a question which I have taught you in yesterday's class. So you can see that it is 1997 JEE mains question. Am I right, everybody? Do you remember, all of you? So we have been found that if a body is moving with a constant velocity, if a body is moving with a constant velocity from a point of axis, that's what. So maybe the angle may changes, but what is not changes, everybody? The angular momentum remains always what? Angular momentum is always remains. Please respond. So angular momentum is always remains mvr or sine theta. So angular momentum always remains constant. That is what we have been found it. Am I right or wrong? Please respond. So that is so r sine theta is always remains constant. So for any, when the object is here, a particle, when it is moving with a constant velocity, so L is equals to mvr sine theta, which is equals to mvr perpendicular. So this r perpendicular only we can say r sine theta, which we have considered as a d. So that distance, that r perpendicular is always remains equal. So we can say angular momentum of a particle who is moving with a constant velocity v, and which is parallel to which axis, everybody? Which is parallel to x-axis. So the angular momentum is always about the horizon. About the horizon is always remains constant. So that is what we have been done in yesterday's class. Am I right, everyone? Please respond. All of you? Yes, Mr.
Yes,
Rudresh?
sir.
Yeah. So now in our today's class, we are going to continue with that. So now write the question. So one beautiful question you can see. See, JEE, the most important practical thing which will happen is here integrating the concepts with the one chapter to another chapter. So based upon that, one question will solve now. So related to this, and then we will proceed. See how this angular momentum concept is related to projectile motion, which you have studied long back. So please, all of you write the question. So this is 1990 JEE mains question. You can see that. So all of you write a ball of mass m is projected with velocity v at an angle 45 degrees with respect to horizontal. Find linear momentum of the ball with respect to point of projection when ball is at its maximum height. When ball is at its maximum height. I hope you all understand the question. Are you clear, everybody? Yes, brothers. So they are asking angular momentum of a ball when it is reaches to the maximum height. So it is a projectile motion. So you all knows what is the maximum height it will reach as h maximum. We already studied. So option A. mv cube divided by root 2z. Option B, mv cube divided by 2 root 2g. Option C, mv cube divided by 4 root 2g. And option D, 0. So these are the four options. Now you observe, you no need to think, you try to solve the question. Once I am explaining, you try to understand the question. So that is. So we all know, we are all familiar with the projectile motion, I hope. So now what they are saying, there is a ball whose mass is how much, everybody? M. Clear, all of you? Which has been projected with what angle, everybody? Which has been projected with a, please respond, 45 degrees angle. 45 degrees angle, that is the angle of projection. So how much is the angle of projection, everybody? Theta is equals to 45 degrees. So now they are asking, so we all knows that when the ball is projected, so if it is the theta means, then horizontal velocity remains constant. Am I right, for those who have studied or not? Horizontal velocity. So here, what is that velocity V? It has been projected. So horizontal velocity remains constant. Projectile motion, you remember. What is the horizontal velocity here? V cos, everybody. V cos 45. Now they are asking the angular momentum of a ball when it reaches to the maximum height. So this is what maximum height. So what is the angular velocity at this, for angular momentum of the ball they are asking. So we all knows that at this point also horizontal velocity remains constant. What is the horizontal velocity, everybody? V cos, please respond. V cos 45. Don't know means get out, no issues, leave it, not interested means. Now that is what they are asking. So at this point, what is the angular momentum? We have to find it with respect to the projection when the ball is at its maximum height. With respect to projection, they are asking. So all of you observe very carefully. So I will draw with respect to the projection. So I will make it, forget about the point. So this is the point mass. So this is the point mass whose linear velocity, what is that? V cos 45, horizontal velocity remains constant. And this is about the projected point, origin point. So with origin point, what is the, this is the line joining. So if I join this line, that is only we used to call it as what, everybody? R. Are you understanding, all of you? Yes, please. Please respond. So
Yes, sir.
it is making with the, now you can see it is projected with the 45 degrees angle. Now if I join the line from the origin to the maximum height, do you think that both angles are equal? Is it equal? No, this angle is 45 degrees. What about this angle? Is it 45? No, it is not 45. We don't know that. So that's what you have to remember. So what is this angle, everybody? Let me assume that angle is theta. What is that angle? That angle is how much? Theta, and the distance is r, and the mass is m. So now they are asking, so we all knows that what is the linear momentum at this maximum height. So this maximum height we used to call something. Anybody can tell me? That is only we used to call as r, r sin theta. So r sin theta is equals to r perpendicular. R perpendicular only, what is that actually? R perpendicular is equals to h max. Understanding? So now what is the horizontal velocity? Let us find that now. What is that? V into cos 45 value. Anybody? Cos 45 value. 1 by root 2. Understanding? So V divided by root 2. That is what. So now what is the linear momentum formula? Linear momentum formula is equals to mass into velocity into r perpendicular. So mass is m. Velocity is what? V by root 2 into L. R perpendicular only is equals to how much, guys? R perpendicular is equals to what? H max. Do you understand, everybody? So that is what. So in projectile motion, can you tell me what is R perpendicular H max formula? Anybody? Maximum height attained by the body. Formula I want it. Let me see, at least anyone will say. Maximum height attained by the body. Any one of you? Formula, please. Maximum height attained by the body. Nobody? Maximum height attained by the body. Projectile motion formula. Not for those? Don't know. Any one of you? Don't know? So the maximum height attained by the body in projectile motion is u square sine square theta divided by 2z. So like this forgetting means no use. You have to remember every formulas. So velocity is v square, sine square. So what is the sine theta? It is projected with what? 45 degrees divided by 2 into g. So which is equals to v square into sine square 40. Sine 45 how much ra? Sine 45 how much? 1 by root 2 divided by 2g, which is equals to v square into 1 by 2 into 1 by 2c, which is equals to v square by how much, guys? V square by 4g. Okay, so you people don't know H max formula itself. So m into v divided by root 2 into H max value is how much? V square by 4g. So which is equals to m into v square v power 1 v power 3 divided by 4 root 2 into g. So that is the linear momentum at the maximum height when the ball is projected. So which option is correct? Option C, m v root 3 divided by 4 root 2z. So once again, I'll explain, all of you observe. So when a ball is projected with the 45-degree angle, all of you observe, 45-degree angle, it will reach us to the maximum height. So maximum height at this point, what is the linear momentum they are asking? That is the question. So now what we have to do it here? So we all know that it is projected with the 45 degrees means with the velocity v. So this will become v cos 45. So horizontal velocity remains constant in projectile motion. So now maximum height attained by that is only we can say r perpendicular, which is equals to r sin theta, which is equals to h maximum. Clear everybody? Now, so that R is not actually 45 degrees. It is line, you have to join it. So this is the theta. So this is not equals to 45. This is theta, I'm assuming. So we have to find this is the R actually. So R at this point, what is the linear momentum? So linear momentum formula MVR perpendicular. That is what it is. R perpendicular, it is H max. So H max formula, what is the H max formula? Everybody, projectile motion, u square sine square theta divided by 2g. So please learn the
2g.
formulas. So that is the formula for projectile motion to calculate the maximum height attained by the body. So you need to know it. Okay. So if you find it, you will get it. H max is equals to v square by 4g. And if you replace it, so velocity v into cos 45 1 by root 2. So that velocity become v by root 2. And h max is v square by 4g. So m into v square into v power 1 is v power 3 divided by 2 to root 2 4 is 4 root 2g. That's all is the answer. So that is how you have to solve it. Any doubt, anybody can ask. Clear it. If you're clear, you can solve. Make sure everybody do it fast. Any doubt, anybody can ask. Once it is completed, let me know. We'll proceed further.
Completed, sir.
Others completed?
Yes, sir.
Yes, sir.
Next concept, right? So next concept is basically related to, this is also one of the most important concepts. So many years they ask the questions related to this in JEE. So in case of object moving in a circle, like you can say a small mass m is moving in a circular motion. So what will happen in this? So it is case of object moving in a circle. So you can see, before going to explain this concept, I want to explain you something, magnetic effects of electric current in class 9. We have been studied that, you might remember, when a current carrying straight conductor, all of you observe very carefully, current carrying straight conductor, if a current is passing from downwards to upwards, that's south pole to north pole or north to south, whatever it is. So magnetic fields which will form surrounding by it is actually a concentric circles. That is what we have studied. Do you remember, everybody? All of you? Concentric circles. 9th class, 10th class I taught you. Correct? So now you can see at any point, if you want to find the direction of magnetic field. So we apply what everybody? Right hand thumb rule. Am I right, everyone? So right hand thumb rule, with the help of right hand thumb rule, we'll identify the direction of magnetic field. Correct or not, everybody? Direction of current and direction of magnetic field we'll find it by using a right hand thumb rule. Now why I'm saying you here, you have to understand. So observe very carefully. If I say here, you can see at this point, if you notice it with the help of right hand thumb rule. So this is the direction of magnetic field and direction of current is upward. And at this point, if I verify it, all of you check it. What is the direction of magnetic field? Inwards or outwards? If I apply right hand thumb rule, it is outwards. Do you understand? This is the arrow indicating what? Everybody, plane. If you imagine a plane, it is outwards. Am I right or wrong, Pradosh? And if I apply here right hand thumb rule, this is the direction of magnetic field. If I apply the right hand thumb rule here, what is the direction of magnetic field? 4 fingers. Your 4 fingers will go into the page or out of the page? Everybody. It is into the page. Am I right or wrong? So into the page, that is what we can say inwards. So this is outwards. See, here it is a 2-dimensional. But if you imagine this is a plane of the paper, you can see when we are applying the right hand thumb rule, so you can see our thumb is always indicating the direction of current and the 4 fingers is indicating the direction of magnetic field. So at this point, you can notice our our 4 fingers is acting towards the west. At this point, it is acting towards the east. And here it is acting what? Everybody. Outwards or inwards? Check it, everybody. Outwards or into the page or out of the page? Everyone, it is? Respond, not what senseless things you people are doing. Out of the page it will come. And here you can see, if you rotate your fingers, what will happen here? It will goes to into the page. This is into the page and this is the out of the page. If you remember this concept, then you can solve now in case of an object moving in a circle. So let us take now, there is a circular track. So a ball or a mass of the body is revolving in a particular point. Now at every point, you have to take it. So now with respect to the center, with respect to the origin or O, we have to find the moment of inertia, angular momentum with respect to the O. That is what is our target. Understanding? So circular moving in a circular point. So with respect to the center, what is the moment of angular momentum at every point? When the object is at here, when the object is at here, when the object is at here, and when the object is at here. So all of you observe that. Okay. So let us start with the first angular momentum at this point. Let me take the mass is m. So we all knows that. So in circular track means somebody remains constant. Radius is remains constant. Am I right or wrong? Now can you tell me what is the velocity at this point? Everybody, into the page or out of the page? At this point, it is acting. Velocity is always perpendicular. Into the page or out of the page? Everybody. It is into the page. That is what I can see. Into the page. So what is the angle between them, everybody? Which is equals to what? 90 degrees. 90 degrees. 90 degrees. Now, with respect to center, we want to find the angular momentum. So angular momentum is equals to mvr perpendicular, which is equals to mvr perpendicular. What is the value? 90 degrees means it is sin 90. We can say 1. So what is the value, everybody? R. mvr perpendicular is only mvr. But what is the direction? That is very important. So as we know, this V is acting into the page and R is acting like this. So can you, if you pass your hands right hand thumb rule and tell me what is your direction of thumb? Thumb is our, you can see, if it is, if our thumb is going into the page, we can get a dot. it is out of the pace, we have to put the cross. Am I right? Opposite I am saying, I think. So if it is into the pace, we have to put what? Cross or dot? I have taught you already. This one. Into the pace and out of the pace. Yes, brothers? Where I have taught?
Into the page cross.
Yeah, into the pace it is cross, out of the pace means it is a dot. Now you tell me, apply your right hand thumb rule and tell me go to R cross V. So because we all knows that angular momentum L is equals to R cross V, R cross P. So now you tell me, if you go to the R cross P, what is your direction of thumb? It is acting upward or downwards or into the pace or out of the pace. Verify it from here to here. See, it is going into the pace. V is acting into the pace and R is like this. Now tell me, what is your thumb? It is acting upwards or downwards? Everybody. Imagine like your notebook. I'll send the video just for 1 minute. So then you can understand. So one case if I'll teach, then it will be clear. Just all of you have a glance. You can see now here say the V is acting into the pace like this and R is acting like this. So if I go from R to V like this, then my thumb is acting upward direction. So that is what you have to remember it. Just have watched that video so that you can move. Okay, make it fast, everybody. So you can notice it here, all of you observe. If you imagine your notebook is your circular motion in front of you, just every point you can check it. So here the V is acting. You can verify. So V is acting like this and R is acting. This is the R. So now if you move here also, R cross V, you can see your thumb is acting. At this point, moment of inertia, angular momentum. At this point, it is going into the pace like this V and R is perpendicular to this. So always what is the angle everywhere? The angle is 90 degrees between them. Am I right or wrong? Everybody? So any point you can check it. So always you can see angular momentum. What is angular momentum direction? Everybody. Angular momentum direction. Any point you can calculate. All of you observe. Angular momentum at this point, at this point, at this point. Every point it will act. Angular momentum remains same. And what is the direction? Direction, if you observe very carefully, what direction it is acting? Check the video and tell me. The video I have sent you. What is the direction of at any point? What is the direction of angular momentum? Everybody, always angular momentum. If you check it, it will act upwards only. Understanding? So it is act upwards. It will act upwards. Every point you can see with respect to this one. So magnitude and direction with respect to the center. Magnitude and direction constant in magnitude and as well as direction. So it is very, very important. Now if you not understand, just 2 minutes I'll send it everything and you can the next concept is, all of you observe, if it is a circular motion, all of you check it. If it is a circular motion, so we all knows that from the horizon, it is same. Now imagine there is an axis of rotation, which is passing through the horizon. So, which is passing through the horizon. Now, we all people knows that this is the actually mass M. And here, let me imagine here also mass M. And here also you can take mass M, and here also that is same mass, circular motion. Now about a point P, which is outside, actually in 10th class mathematics drawings you can draw. About a point P, which is outside from the track, you can draw circular track. So you can draw tangents. Do you remember, brothers, if you expand the tangents to the circle? So R is remains constant if you draw the tangents at any point. Am I right or wrong? Everybody? Please respond, guys. Everyone.
Yes, sir.
So about this point, what is the angular momentum? That is what they are asking about this point. So imagine if I imagine here or here the point. So R is always remains constant. This R and this R, whatever it is, R is remains constant everywhere. But direction, what it is, everybody verify. So if I imagine at this particle now, so R is acting, this is R. but you can see velocity will goes like this direction. If I come R cross F, always the angle between them is how much? Angle between them is 90 degrees only.
90 degrees.
But the direction is keep on changes. At this point, you can see velocity will be like this, R will be like this. So the angle between them is 90, but here angular momentum is acting like this direction. At this point, angular momentum is acting like this direction. So if you notice it, the angular momentum about the point P, for example, at this point, if I check here, MVR perpendicular, which is equals to MVR, R is remains constant. Actually, about a point, you draw a tangent, you can see. Drawing actually, the chapter is deleted, I don't know. So you can draw what is the points it will be. Like drawings, 10th class drawing the circle, what is that motion? The chapter is deleted for you. So there we can draw. So this R is always tangents to the circle from the outside the point. So always R is remains constant only. So you can draw from any point it is. So now if you notice it here, you can see the magnitude at any point you can check it. Magnitude is remains constant. MVR perpendicular is equals to MVR. So that magnitude is remains constant. But what is not remains constant about a particular point P? Actually, so this angular direction of the angular momentum is not remains same. Direction of angular momentum is keep on changes, which you have taken the point out of the circular track. So it is not remains constant. So we all knows that angular momentum is a vector quantity or scalar quantity. Everybody, it is the vector quantity. So we can change.
Yes,
Vector quantity means what? It is depends on both magnitude and as well as direction. So
Direction.
magnitude is remains constant, but its direction is variable. So because of this, so it is a what quantity actually? It is the vector quantity. So
Vector quantity.
R is remains constant. Keep in mind, if I say circular track, if I take the point P outside the circular track, if I draw a tangent at any point, you can see. So R values remains constant, but the linear direction of linear momentum is not constant. So that is why we can say, based upon this, all of you remember, if I take a point anywhere outside the point out of from the circular track, keep in mind, from based upon the center, the angular momentum based upon the centers is always remains constant. But out of the pace, out of the circular track, if I choose the angular momentum for a particular point, it is not remains constant. Magnitude is constant, but which is not constant, everybody? Which is not constant? Direction is not constant. So based upon this concept, exactly the same concept alone, 2014 and as well as 2012, 2 years they asked the question. 1 year they asked both about the point outside the circular track. So outside the circular track, if you check the angular momentum, remember at every point the direction of angular momentum is keep on changes, but what will happen? The magnitude is remains constant. But if you check the angular momentum through the center, origin, the angular momentum, magnitude as well as direction both remains constant. That is you have to remember. But what is the angle everywhere? If you check at any point, what is the angle between them? Everybody. The angle between them
90 degrees.
which is equals to what? Everyone. 90 degrees only. So they are perpendicular to each other. So, but their direction of angular momentum is not, remains constant out of the circular track point P, and inside from the origin, from the center you can check it. So from the center, magnitude and direction is remains constant. Outside, only magnitude is constant, direction is not constant. That is what you have to remember. Understand? Everybody? Princey, Mr. Rishi, Rohit. So that is only 2 points. Based upon this, 2 years, 2014 as well as 2012, both years they asked the question. Direct question it is. Okay. So which is constant, which is not constant. So in LP, all of you remember, in linear angular momentum about a particular point is magnitude is constant. Magnitude is constant, but what is variable, everybody? Direction is variable. Okay, but if you take angular momentum about the origin point, it is always magnitude is also constant, and as well as both direction and magnitude is what remains constant. That is only magnitude and direction remains constant. So very important concept this is. Okay, so please all of you remember. Next, so this is what about the angular momentum of a particular point mass. Now we are going to derive the derivation for angular momentum. So please write it. Next concept. So angular momentum of purely rotating body. Angular momentum of purely rotating body. Okay. So let us take, we all know if it is a purely rotating body, we all know something is remains constant. What is that, everybody? If I take infinity number of particles, each particular angular velocity remains what, everybody? If I take a random body, so which is rotating about a fixed point. What is this point, everybody wish to call as? All of you? Pivoted point. Understanding?
Pivot.
So it is moving with the angular velocity omega, angular velocity omega. Now we all know that what is the linear momentum formula? Linear momentum is equals to R cross, everybody. R cross phi P. Now R cross P means what, everybody? Linear momentum. Linear momentum means what? M cross V. Next one, M into R cross V I will take. So R cross V means something. Anybody can tell me? R cross V means R perpendicular, R sin theta. So this is already we know that. Now, so angular momentum of a purely rotating body. How to derive it? Derivation. So all of you observe, it's very simple. So we all know that at a particular mass, if I have taken, what is the angular momentum? We got it, everybody. MV are perpendicular. Am I right or wrong? Everybody, point mass. Please respond. So let me take, this is the point mass inside the body. Infinity number of points is there. I'm taking M1. This is the point 1. So at this point is revolving like this. So at this point, its velocity is V. Now I'll join from the pivoted point. What is that called as? Let me take, this is V1. Okay. And this point is R1. So can you tell me what? This is R1. So now you tell me what is the direction of angular momentum. Apply your right hand thumb rule and tell me, please. Everybody. Upwards or inwards or outwards or downwards. Anybody? Go with the R cross V. R cross V. We have to go. It is, tell me, it is acting outwards or inwards. Everybody. Anti-clockwise, guys. It is anti-clockwise. Anti-clockwise. Check your hand and tell me. So let me write the angular momentum about that particular point. L1 is equals to M1 V1 R1. So tell me what is that, outwards or inwards? For those what you are getting, your hand. You can apply on my screen also and you can tell me. Everybody. Yes, please. Go with the R cross V. Everyone. What is that? Upward or downwards? All of you.
Upward.
It is acting upward. So upward means what? It is. Actually, it is outward. So it is acting outward.